Hey all, Grolo here. Whew, it's been a week. I'm very happy it's Friday. Hope you all are having a great Friday and getting settled in for an awesome weekend. You may have noticed, or actually, probably you didn't. So trust me when I say, there's been a few minor changes around the channel. I restructured the channel page a bit to bring some more order to the various types of content that I've been experimenting with. And I stopped the videos from auto playing on that channel. Sorry, that was freaking annoying. Me at least. And it's my page. I also started experimenting with shorts as a smaller window into the bigger conversations. We'll see how that goes. And that's it for that. But I'm open to feedback on any and all of it. I'm still trying to figure this stuff out, so very open to y'all's thoughts. Now, I know they put out Star Citizen Live a day or so ago, titled Content Driven, but I'm going to be honest, I'm just not interested in it. I'd be doing you all a disservice by putting up a video on it. I'd just be doing it just for the sake of putting up a video, and that's not me. I'm not here to play missions. I'm here for the sandbox. And I know they're not mutually exclusive. I hope that someday missions will be done in a very great way that helps bring the sandbox more to life, and that would be awesome and amazing. But for now, I just don't care enough, and I don't think I would add much value at all to the conversation. What I did want to do today, though, is continue to do over the next little while is break down small sections of that huge 4-hour long Star Citizen Live and More Stable Universe reaction that we did. Make smaller, more focused videos on some of the topics in there. We'll take a more technical look at a topic when it makes sense, or whatever approach we need to take. If there's topics you'd like to dig into, drop me a comment anywhere. This video or that video, don't matter. I'll find it. So kicking off today with one I think I can explain pretty quick. This was a comment by Carrie GG. They asked, please go further on the dual writing on a dedicated video. Thanks for the comment and the thought, Carrie GG. That's what we're going to do. Before I break out the whiteboard, which is going to be the best way to visualize this and kind of describe it in a way that y'all will pick up on in no time, let's just roll the small section of the reaction video that this question pertained to, just so people have more context.
There was one I was looking into with a player actually recently where when you read your inventory, there's caching going on, right? And when your inventory changes, that cache is supposed to be expired. In certain locations, for some reason, that cache, especially in CZs, was causing some problems. So opening your inventory in the CZs would be empty, and then you open it again, and then you store something in it, and now other items show up. That's a telltale issue of the cache. So we're actually revamping the query cache right now.
Hard things in computer science. Naming things. Cache invalidation.
Now, for these elements to make sure it's always consistently updated. Your stuff is there. It's just
can't show.
It's cached as nothing. Yeah, exactly.
With long-term persistence, it seems like there's it seems like there's always some level of something disappearing.
Yeah.
Every patch.
Yeah.
What's going on here?
So LTP is a fairly complicated system, right? But if I can simplify it as much as I can, when you stow something in an inventory, and we take that item and we process it. So let's take a easy example. Let's say a single gun. You have P4. You have a P4. You put it in an inventory that you own. a record is created for it's an ownership record that says this player owns a P4, right? Now these records we write to all the time. If you unstow that gun, meaning you put it in your hands, right? We destroy that record because now it's in play. So you play with the gun and then you stow it back. That recreates the record. So these records should always represent what you've got in your inventory that you own. Now, where it gets complicated is that these things can be hierarchies that contain items that then need to be processed. And so we don't persist everything to LTP. Only a select set of entity classes that designers control will go into LTP. For example, ships is a good example, things like that. Now, when we stow a ship, we look at its entire hierarchy, and there might be things attached or loosely left in the ship that are LTP.
On the list.
I don't know if he's saying these records are deleted and recreated conceptually, or if that's literal. Especially considering that entity tracking, as far as I know, well, unstowed entity tracking takes place in the entity graph, which is a graph database, and it really depends on how they implement it. But another approach would be to have an entity not be created and destroyed, but rather just moved. Right, so like a rifle in a box. You take it out of the box and put it in your backpack. That arrow that connects your rifle to the box now just moves, so now it's connecting your rifle to the backpack. That'd be another way of doing it. But I do know that they've talked before about, I forget what they call it. I covered it in one of my past videos. Basically, they have another database that handles like stowed things. So if a rifle in your station inventory is considered like a stowed thing in some way, then maybe that is literally like a record being created in that database, and whenever you take it out into the world, it's deleted there, and now it's created in the entity database. That would be interesting. That's a possibility.
Correct, and now they have to be added in. So the also with LTP, there's also sometimes perception issues that things should persist, right? Like for example, a classic case is a ship left in the shard between patches, right? You're flying your ship in 324 and we release 4.0.
Global database
if
is
you
what they
leave the
call
ship
it.
there in the shard,
Non-entity
right?
database.
You don't have an ownership record for it, right? The ship needs to be stowed.
Gotcha.
In order to be there when we recover it. But we do think that there are still issues with some of the recording events in cases where ships are claimed, because at that point, when you join into the next patch, let's say you have a ship you bought with UEC and you store it at a location. That ship actually, its recorded ID comes from your long-term persistent record of that ship. And in the case where you claim that ship again, we think that there might be some cases where the inventory, the record data doesn't follow, and so the LTP record is not recreated. And that could be a source of some of the lost ships in the LTP data. But overall, we're not happy at all with that solution in general. And
I don't know because I can't see the code, but just based on what he's saying here, this sounds like it could be like a dual write error, where so like dual write is a common problem whenever you're dealing with multiple data stores, and like you need two data stores to be updated and changed to reflect an action somewhere else, right? Like in this case, it's in the universe. So like if I take a rifle out of my backpack and I put it in my station inventory, if that does indeed require like the removal of the entity from the entity graph and the creation of a record in the global database, that's a dual write. You're removing it from one place, you're putting it in another place, two writes. Now, the reason why dual writes are bad is because anytime you have a situation like that, you are running the risk that it falls out of sync. Like half of the operation fails the other half succeeds. Now the state is wrong, right? There's nothing you can do within reason to make that foolproof so that it always either all fails or all succeeds, which is the desired situation. Now, one way you traditionally overcome this is that you ensure that the application or the service or the game server in this case is not responsible for both writes. It's only responsible for one. And then the infrastructure handles propagating that change to the other systems. So, for example, often what is done in large scale implementations, I'm not going to go too deep here because I know we're blowing the time way out. So if you're interested in me going deeper on this and illustrating it, drop a comment. I can go further. And what we do in large scale places is we'll put like a log in between, right? Like a distributed log like Kafka or something like that. So that whenever you manipulate the entity graph, that manipulation is written to a log file on disk, and you only return success to the client if the change has been reflected in the database in memory and the file on disk, the log. Otherwise, the client doesn't get a successful message. The inventory operation's a failure. Because once it's in that log file on disk, we can guarantee it makes it into Kafka. We can guarantee it makes it from Kafka to the global database. All right, so you take an action on the entity graph, you remove the thing from your backpack and put it in the station inventory. Record gets dropped to disk to Kafka, the global database. You can guarantee that cycle completes. So that's one way to eliminate the dual write. Okay, once again, Carrie GG, thanks again for taking me up on my offer to dig into this. So here we go. It's whiteboard time. This should be pretty quick. Okay. I've already got us a few things on the screen here to get us started. But let's visualize what a dual write is. So let's take the example that they were talking about in the video, or we were talking about, where you have a stowed ship. And we all know, or I think we know, that stowed ships are stored in the global database. Ships that are actually in the persistent universe are stored in the entity graph database. And so we have these two databases on the screen here. Now, there's a few ways of implementing this, right? One way would be the user that I have up here representing the client application, or the actual Star Citizen game client, does everything. Now, there's going to be a bunch of layers involved here. We got the game server, we got the replication layer, and all kinds of stuff going on. I don't want to complicate this. I want to focus on what a dual write is. But I am going to talk about a few different ways. One way is that the client application does everything. Let's just say our ship, our Connie is currently stored, and we want to unstow it and get it into the world. So there is a record in this global database here that represents our Connie. Our client has to do two things. It has to talk to this database and say, delete the Connie record because it's no longer going to be stowed. Or it has to update it in some way, right? It has to maybe update a flag in there. Maybe the record stays in there, but it updates it to like unstowed or something. And it also has to talk to the entity graph database and say, hey, insert a Connie record because I am bringing a Connie into the universe. So that's a dual write. A write doesn't mean that you're like a lot of times people will equate a write to creating something. And you're like, but Grolo, wait, we're deleting in one place and creating in the other. Yeah, a write is anything that changes the database, right? Anything that's not a read, basically. So we're deleting in one, we're creating in the other. Now, the thing is that any operation like this, any IO operation, input output, can fail at any time for any reason. Let's just say your client attempts to dispatch these two things and the network blips really, really quickly. And one of them fails and the other one succeeds. Maybe the delete fails. So now the ship is both stowed and in the universe. We've just duplicated the ship in that case. Or maybe maybe adding it to the entity database fails. Well, in that case, our ship is now unstowed and it's now nowhere in the world. Right? So you can see really quickly how we can get an inconsistent state because of dual writes and the fact that they fail. And things like this fail way more often than you would think. Okay, so, well, that's not great. How could we improve this? Let's undo that. Let's take another stab at this, right? Let's maybe have like the event layer in here. Remember, like in Star Citizen, we've talked about this a lot of times. Like everything you do in Star Citizen is an event. Like you push an elevator button or you touch a button on the ASOP terminal, all that fires off an event. Like, hey, Grollo is summoning a Connie. So let's put an event out there. This dotted line represents our event traveling around. It's going to travel to a consumer, is what we call this. So this consumer is listening for ASOP terminal button events. So it sees this ASOP terminal button event. It says, oh, I know what to do. I'm going to delete a record from the global database and insert a record into the entity database, right? We still have a dual write. We've taken the dual write away from the client and we moved it inside of the data center, which is good because you're going to be far more error prone coming from the public internet where the Star Citizen client is running out on some player's desktop in Kansas. You've taken it out of there and you've moved it. So now the player just fires an event. The event travels inside of your data center onto this little thing that's listening. And now this thing handles the dual write. So that's better. You're less likely to have a failure, but it's still a possibility. It's still a strong possibility. Because even within a data center, there's a lot of moving parts. So this isn't as good as we want it to be. Let's try again. Let's put our ASOP terminal button listener right here beside the global database. The only thing it does is update a record in the global database and say you're unstowed. Right? Now, global databases they have logs. And there's a big long file associated with this database, and what this file does is it records all changes to the database. Usually called like a WAL or a wall or a write-ahead log or something of that nature. These are often used for like replicating databases. If you want like a real-time copy, you'll use this to replicate them and so on and so forth. But there's other uses for them. And one use is what we're about to do right here. So our ASOP terminal button listener unstows the ship. The fact that was changed in the global database gets written to a log. We have another listener here. And his whole job is to scan this write-ahead log or this global database log file looking for changes where a ship changes from a state of stowed to unstowed. So it's going to see this change and be like, whoa, Grollo's Connie just transitioned from stowed to unstowed. I got a job to do. It drops that job onto a queue or a distributed log like Kafka, SNS, SQS. There's a whole bunch of ways to queue it, but it's a queue. And this is basically a job queue, and things go here to be done. And these queues are durable, and they have basically an acknowledgement process. So you can confirm whenever a task that is sitting in a queue is done. And until you confirm that it's done, the item in that queue will remain there. So you have another listener on the other side of this queue that is just listening for tasks coming off of this queue. And it's updating the entity graph for every job that comes off the queue. It says, hey, you need to put a ship into the universe because one was unstowed. So we need to now put it in the universe. So this thing's only job is to read from that queue, insert a ship into the entity database so that it appears in the universe. Once it's successfully inserted the new record into the entity graph database, it has verified it, it knows for a fact that it is written, it then acknowledges to the queue, says, hey, this is done. And finally, that task vanishes from the queue. Now, every step along the way here, you have guarantees, right? Except possibly the event coming from the user, but the user can just retry. If he hits a button and nothing happens, he gets to hit the button again. That's fine. Some places we're willing to tolerate some level of error. Now, if we wanted to, we could extend this the whole way to the user, but for now, we're just going to say, you know what? The user gets visual confirmation that things are working. He hits the button, elevators start doing things. Okay. If they don't start doing things, he'll hit it again. That's fine. So that sends an event. Our ASOP terminal button listener writes to the global database. It gets acknowledgement, by the way. On a database, you have various settings where you can control the acknowledgement level. So it depends on like your tolerance for consistency versus performance and all that stuff. But you can tune this global database so that we don't actually acknowledge the receipt of this record to this listener here until we know that it was written to the log. Other options we have are we could acknowledge to this listener as soon as it's in memory. But that would be bad because there could be some failure between it being written to memory and written to the log, and we could lose it. I mean, it may, if we're lucky, be inserted into later, but we could lose the whole thing if we do that. So we set our acknowledgement level to only act the right to the first listener here once it's in the log file. Okay, so guaranteed it's in the log file. Once it's guaranteed in the log file, this listener is reading it from the log and putting it in the queue. Now, there could be a failure at this point. That thing could read from the log, try to put it in the queue, and fail. Right? The request to the queue could fail. The network could be interrupted. Something could go wrong. So the way that is managed is you do get an acknowledgement from the queue once it's in the queue. Once you get that acknowledgement, this listener records a little state, right? In itself, it tracks the last position in this log file that it got a successful acknowledgement from the queue on. So if it's going through 1,000 lines of the log file and it's on like 5, the number inside this listener will be 4 because we've gotten 4 acknowledged. Now we're on to 5. We try 5. Did we get an acknowledgement from 5? Yes. Okay. We increment our internal number to 5. Now we go read line 6. Try to put 6 in. Did we get an acknowledgement? Oh, nope. The queue blew up or the network blew up. Something happened. Okay. We do not increment our internal number. We sit there and we wait and we retry number 6 again and again and again and again. Eventually, it'll work. We increment our internal counter to 6. Now we're on to record 7. And that's how you can guarantee this step of the whole process. And then, of course, we know the final step. We have the thing reading from the queue and insert into the entity database. It gets an acknowledgement from the database as soon as it hits the disk drives in that database, and it empties it from the queue. And so in this way, we've taken a dual write that is very brittle and prone to like state inconsistencies and weird things happening in the universe, like my ship vanishes or it goes unstowed for no reason or it's lost and I got to claim it. All that stuff is solved by implementing a workflow such as this. So cool. I hope that quick illustration was helpful and the explanation helped carry GG. Once again, thank you for your comment. And I hope this made it clear what a dual write is, why it's undesirable, and how it can be done better. I don't know if this accurately describes what's going on behind the scenes of CIG's inventory bugs that they were talking about, but it sure could be. It could be it, or it could be part of it. Only they will know for sure. But with that said, I say thank you for being here and watching and for all the great discussions we continue to have. Please head to the comments. Let me know if there's anything in this video that wasn't clear or you'd like to know more about. Then let me know what we should talk about next from the marathon, more stable universe of Star Citizen Live. We'll keep on going until everyone's good. And finally, all these videos are brought to you by me and my other passion, which is Unhinged Gaming and the Luminous Corporation. Visit us at unhinged.gg or luminous.gg. Links will both be below. And once you're there, follow a link to Discord to get involved with that passion of mine. I would love to have you there. We're always looking for more great people, and I know this channel is full of great people. Again, for that, I say thank you. And that's all I got. I hope you all have a great weekend. I got a good video cooking for Monday where we take a look at things going on this week. It should be interesting. I can't wait to dig into it with you. And with that, Rollo out.